You know when you're at the doctor's office and they tap your knee and your leg just kicks out all by itself? It kind of feels like magic, right? Well, it's not magic, but it is an absolutely fascinating peek into your nervous system's incredible autopilot. So let's get into it.
It's such a simple question, but the answer is surprisingly cool. I mean, this isn't a choice you're making. You don't decide to kick your leg out. So, what in the world is pulling the strings? Let's trace the signal and find out.
Okay, so picture this. We've all been there, right? You're sitting on the exam table, your legs are just dangling, and the doctor pulls out that little rubber hammer. They give you a quick, gentle tap right below your kneecap. And boom, your lower leg just swings forward. You didn't tell it to do that. In fact, you probably couldn't have stopped it if you tried. And that automatic response, well, that's the whole key. It's an involuntary reflex, and it tells us so much about how our bodies are wired. To really understand this, we need to become a signal for a second. We're going to follow the electrical impulse on its lightning-fast journey. It's a trip that starts at your knee, zips up to your spinal cord, and comes right back, all in a fraction of a second. So this path has a name. It's called the reflex arc, and this slide lays it out perfectly. Let's walk through it. First, the hammer tap stretches your big thigh muscle, the quadriceps. That's step one. Instantly, step two, these tiny sensors in the muscle called muscle spindles freak out a little and fire off a signal. Now for step three, that signal rockets up a sensory neuron, heading straight for your spinal cord. And here is the most crucial part, step four. Inside the spinal cord, that signal gets passed directly to a motor neuron. It's like a direct handoff. That motor neuron, step five, immediately sends a command right back down to that same thigh muscle, telling it to contract. And the result, step six, your leg kicks forward. So, did you notice what was missing from that entire journey? The brain. Your brain had nothing to do with it. This whole reflex is a brilliant shortcut designed for one thing and one thing only: speed. It completely bypasses the brain to save precious milliseconds. The official term for this is a monosynaptic reflex. Let's break that down. Mono means one. A synapse is just the connection point between two nerve cells. So monosynaptic means there is only one single connection in the whole circuit. That incoming sensory neuron talks directly to the outgoing motor neuron. It is the absolute fastest way your nervous system can possibly respond. No detours, no waiting for approval. Right. So your spinal cord basically acts like a local command center. It makes the call instantly. Your brain does get a message, but it's more like a memo that says, by the way, the leg just kicked. It finds out after the fact. That's why the whole thing feels so instantaneous and out of your control. Because it is. And this slide does a great job of showing why that's so special. Let's compare it to something like pulling your hand away from a hot stove. That's a polysynaptic reflex. Poly meaning many. The signal has to go through these little middlemen called interneurons in the spinal cord. They allow for a more complex response, sure, but they also add a tiny bit of a delay. The knee-jerk reflex says, nope, we don't have time for that. It sacrifices all that complexity for raw, unbeatable speed. Now, this is where it gets really wild. Our diagrams make it look like one neuron talking to another, right? But in reality, we're talking about a massive team effort. That one little tap from the doctor, it activates hundreds of sensory neurons all at once. And get this, each one of those connects with about 50 motor neurons. It's this huge amplification that creates a strong, coordinated kick, not just some little twitch. And if that wasn't genius enough, there's another amazing thing happening at the exact same time. While your quad muscle is getting the signal to contract, a parallel signal is sent to the opposing muscle, your hamstring, telling it to just chill out and relax. This makes sure the kick is smooth and doesn't have any resistance. It's like hitting the gas and taking your foot off the brake simultaneously. Just beautiful coordination. Okay, so it's a super fast, incredibly efficient neural circuit. We get it. But why? Why do we even have this? Well, it turns out this simple little kick is actually critical, both for how your body works every single day and as a really important diagnostic tool for doctors. So, it's got two critical jobs. First, for your body, this reflex is working all the time in the background. When you're just standing or walking, it's making these tiny rapid-fire adjustments to your muscle tension that help you keep your posture in balance, all without you ever thinking about it. And second, for your doctor, it's a super quick and reliable checkup on your nervous system, specifically looking at the health of the pathways in the lower part of your spinal cord. And by watching how your leg kicks, a doctor can learn a whole lot.
If there's no reflex or it's really weak, that could point to nerve damage. If the kick is way too big and jerky, it might signal an issue somewhere else in the spinal cord or even the brain. It's a surprisingly useful window into your neurological health.
So let's just zoom out for a second and look at the big picture here. This really isn't just about one muscle and one weird kick. It's about all the amazing automatic systems that are running your body 24/7 without you ever having to lift a finger.
And really, this quote sums it up perfectly. It's a simple circuit, but its whole job is to help us maintain posture and balance. Every time you shift your weight or stumble a little bit, this type of reflex is firing off, keeping you stable, keeping you upright.
And that's the real takeaway here. That strange little kick at the doctor's office. It's a perfect demonstration of the hidden, high-speed autopilot that's constantly managing your body. It's proof of the incredible efficiency of your nervous system, running these complex programs every single second of the day, just to keep you going.
It really makes you think, doesn't it? I mean, right now, as you're sitting here listening to this, your heart is beating, you're breathing, your eyes are blinking, all on their own. So what other incredible automatic programs are running your body this very second, completely without you even noticing?